Okay, this is exercise 4.8, question 9. In this question, we have to show the triangle PQR is right-angled. Please do not put a right angle symbol in there. You are trying to show that it's right-angled. Okay, I've just labelled the triangle PQR. So, for right-angled triangles, we know that Pythagoras' theorem... triangles, Pythagoras' theorem applies. So we will know that, for example, PQ squared plus QR squared, that's okay. So we'll know that, girls, for right angle triangles, the sum of the two shorter sides squared should equal the longer side squared, okay? So that's what should apply for Pythagoras' theorem. If it is, look, if it's a right angle triangle, Pythagoras' theorem will work. Okay, girls, this is a PR. So PQ squared plus QR squared equals PR squared. Now that will work if it's a right angle triangle. So let's look at what PQ squared plus QR squared is. Let's just have a look at that separately. And what is it, girls? What's PQ? A squared plus, what's QR squared? A. So PQ squared plus QR squared is A squared plus A squared, which is 2A squared. No, it's two lots of A squared. We're adding and subtracting in algebra. You can only add or subtract like terms. They are like terms because the pronumerals are identical. So therefore, A squared plus A squared is 2A squared. We can also now look at this right hand. So we've just done that bit and we got 2A squared. We're now going to do the PR squared. Isn't it just A root 2 squaring it? So, which means it's just A root 2 times A root 2, isn't it?
So it's 2A.
So, no, so it's really A root 2 times A root 2, times A root 2. What's A times A?
A squared.
A squared. And what's root 2 times 2? So it's also 2A squared. Can you see that? Girls, that's just a normal A there. I could have just said A squared is A squared, root 2 squared is 2, or I've written it out here that A root 2 squared is A root 2 times A root 2. A times A is A squared, and root 2 times root 2 is 2, giving us 2A squared. Can you therefore see that PQ squared plus QR squared equals PR squared, because we just showed that both of them are 2A squared. Can you see that?
Yes.
That squared is 2A squared and this squared is also 2A squared, and so therefore Pythagoras' theorem applies for this triangle. Pythagoras' theorem only works for right angle triangles. All right, now I'm going to show you that with just numbers. If I do, just showing you, for example, 3, 4, 5, we know is a triad, don't we? But we know that this won't be right angled, but I'll draw it right angled. 3, 4, 6 is not a triangle. It's not a triad. Just using this concept, you know my two shorter sides? What's 3 squared plus 4 squared equal to? Well, no, what does it actually equal? 9 plus 16. And what does 5 squared equal?
25.
So can you see that? So therefore 3 squared plus 4 squared is 5 squared. That works. So therefore Pythagoras' theorem works. So therefore this is a right-angled triangle. Now this triangle here is not. Let me try. What's the two shorter sides squared?
25.
What's 6 squared? So therefore 3 squared plus 4 squared does not equal 6 squared. So therefore it's not a right-angled triangle. Yes, yes. Girls, now, see these examples here with numbers. What you're doing up here is the same as what I've done here, but this is using numbers. That's using pronumerals and algebra. But the concept and the idea and how you approach the question is the same. So this is a right-angled triangle, yes. So this is now doing this question, an example with numbers, showing the principle behind the method. Do you get the idea? I'm doing two shorter sides squared, seeing what I'm getting. Because you know for Pythagoras, that a squared plus b squared will equal c squared, but only in a right angle triangle. That will only work. Pythagoras' theorem is only used in right angle triangles. If you try and apply Pythagoras' theorem and it doesn't work like this one, then the triangle is not right angled. To do this, because you have to show that AD equals 2 times AB, if you let AB equal X, right, so otherwise you're going to have to talk about all these sides with no values and it makes it really hard. So if I let AB equal X, we know that those two are equal. So we go AB equals BC equals X. You don't need to put a reason for this. It's not proving. It was given. Now, what could you do next? Girls, I've got two sides of the first triangle.
Yeah, try to figure out your AC and then so you can do the hypotenuse.
Good. So in triangle ABC, I'm going to use Pythagoras' theorem. Don't I know that I'm trying to work out AC squared, aren't I? I'm trying to work out AC. AC squared isn't it just x squared plus x squared? Isn't this triangle, the longer side, the hypotenuse equal to x squared plus x squared, which is 2x squared. Now, girls, I'm actually not going to work out what AC is, because tell me what I'm going to do in this next triangle. AC squared, yeah. So aren't I just going to say in the next triangle, in triangle ACD, aren't you just going to use AC squared plus which one squared? Plus CD squared is what? No. That squared plus that squared is AD squared. Girls, do you know why I'm doing that?
Oh, yeah.
Girls, I'm going to keep this as AC squared. Do you know why? Because once I've worked it out, now I've just worked this out, it's 2x squared. Tell me what else you know. If that's 2x squared,
CD equals 2x.
so therefore CD equals 2x squared as well. So I'm going to go, therefore CD squared is equal to AC squared, which is also equal to 2x. Oh, girls, I'm very naughty here. That's not 2x squared. That's right. So just leave that. Yeah, don't write it in. Don't write it in. It's root. All right. If I want to work it out, all right. Watch. No,
If you cancel out.
Vanessa.
Yes.
AC squared is 2x. Girls, I'm just going to show you why I'm not even going to bother doing it. It's the square root of all of that. Now, square root of 2 is root 2. Square root of x squared is x. But girls, I don't even want to work that out. I'll tell you why. Because when I use the next triangle, I'm not going to use just AC. I'm using AC squared and CD squared. So you may as well just leave it like that. All right. Now, because I know that AC equals CD, therefore CD squared will equal AC squared, which is also equal to 2x squared. So I'm actually not even going to bother working and writing this out on the diagram, because I know I've got to square it anyway.
What's that apostrophe thing? Is that linked to
No, that's just a star.
Is that linked to your working out?
No.
We don't do the line underneath.
Look, yes, write this out. Girls, look. Girls, down here, if AC is equal to CD, then it will follow that AC squared is equal to CD squared. Does that make sense? If that side equals that, let's say they're both 5, for example. If AC is 5 and CD is 5, then that could be, AC squared would be 25 and this would be 25. So what I'm saying here is, because we know that AC equals CD, therefore it'll follow that AC squared equals CD squared. All right? Now, I'm actually not going to work out what AC is over here, because I know that in my next line of working, so I've got the AC squared is 2x squared from my first triangle, right? But now I'm saying, well, I know that AC equals CD, so therefore AC squared will equal CD squared. So I can say, well, CD squared is the same as AC squared, which is 2x squared. Now, in this next triangle that I'm going to use, I use that squared plus that squared is this squared. So I'm not going to bother working out what AC is and what CD is. I'll just keep the squared versions of them, because that's what I'm going to use next. Does that make sense? So what's AC squared? Wait a sec. What does AC squared equal? And what does CD squared equal? Equals AD squared. I'm trying to work out what that is. So AD squared is what? What's 2x squared plus 2x squared? Now, so therefore AD will be the square root of 4x squared. So you have to square root the 4. What do you get? No. You square root the 4 and you get 2, and then you square root the... Alright, so girls, that's the same as the square root of 4 times x squared. Do you get that? So it's the same as the square root of 4 times the square root of x squared. So that's what you do. When you do the square root of 4x squared, what you're saying in your head is I square root the 4 and I square root the x squared. What's the square root of 4?
2.
What's the square root of x squared? Now, 2x is the same as 2 times, what does x equal?
AB.
So it's the same as 2 times AB. So therefore, AD equals 2AB. Because x is AB up here. Can you see that? There you go. Wait, I'm trying. But the problem is people up the back may not see. There we go. Which one?
To get AC, you just do normal Pythagoras.
No, to get A, yeah. What, for the first bit?
You can do it the normal long way.
AB squared, so that squared plus that squared equals AC squared. If you want to work out AC, you'd have to square root that. But I don't...
So to do it, is it just x squared plus x squared equals AC squared?
Yes.
And then you...
Add those two together and you get 2x squared.
Okay, I get it.
Now, do you know why I didn't bother just working out what AC and CD are? Because I knew in the next step that I had to do AC squared and CD squared. So I thought just keep it like that. Girls, ladies, shh. For those that missed this, you may want to watch the recording later. Has everyone written this down? It's just you three? Girls, question 13, can I just minimize this for a sec? I'll just write it up. Question 13A, prove that, stop, 2x, x squared minus 1,
Are we doing this?
yes.
Miss, the video's still on.
Why are you guys staring at me while we're doing this?
Girls, we're doing question 13. It's okay. Shh. Question 13's down here. Have the girls that have just walked back in written the top bit? That's question 13. Prove that 2x, comma, x squared minus 1 and x squared plus 1 is a Pythagorean triad. Tell me what a Pythagorean triad is. Good. Tell me how that 3, 4, 5 works. That 3 squared plus 4 squared is 5 squared. So in this example, we don't have 3, 4, 5. We have 2x, x squared minus 1 and x squared plus 1. So we're going to use that same principle. Which two do I add together?
X squared minus 1 and x squared plus 1.
I add the two. The first two will be the smaller ones. And the last one should be the hypotenuse.
Okay.
So I want to prove, this is what I need to prove, that this one squared isn't a Pythagorean triad. What's Pythagoras' theorem? A squared plus b squared equals c squared. So I need to prove that a squared, or 2x all squared, plus x squared minus 1 squared is equal to what? So that squared plus this one squared equals x squared plus 1 squared. That's what I'm trying to prove. This is Pythagoras' theorem. So this is what I'm trying to prove. That's what I need to prove. Now you might want to keep your left-hand side different, separate to your right-hand side.
Also, you can put it
So left-hand side is 2x, no you don't. You're trying to prove, you're trying to see what, girls, this is what you're trying to prove, that a squared plus b squared is c squared. You know what you should do? Work out your a squared plus b squared first. No, it's a perfect square, that one. So, how do you expand 2x squared? You square the 2 for x squared. This is what we call a perfect square. This is like a minus b. I'll write the rule here. A minus b squared is equal to, what's the rule?
Miss, wouldn't that be x?
A squared minus
2ab plus b squared.
Sorry, that's a mess. Ladies, a squared minus 2ab plus b squared. Shh. That is how you expand a minus b squared. So, that is of that format. What do? I square the first one. What's x squared squared? X to the 4 minus 2 times x squared times 1, which is what? Minus 2x squared plus the last one squared, plus 1. This is what my right-hand side is equal to. x4, there are no other x4s there. What about the x squareds? They're like terms. So I get 4x squared minus 2x squared is plus 2x squared. What else have I got? Plus 1. That's what my left-hand side is equal to.
Miss, we can factorize that.
Wait, I need to prove that the left-hand side equals the right-hand side. I've just done 2x squared plus that squared, and I've worked it out, and I get that. Now I have to look at what the right-hand side is. X squared plus 1 squared, and I need to expand it. And hopefully I get that answer. Does that make sense? What I'm doing, girls, you know how I did that 3, 4, 4, 5 triangle before, and I did 3 squared plus 4 squared, worked it out? Then I worked out the 5 squared, worked it out, and I saw that they were the same. Well, I'm doing the same thing here. That squared plus that squared, work it out, and then do the other last term squared and work it out.
Can't we do something to that?
Yes, this again is a perfect square. It's of that format, a plus b squared. How do I expand that? A squared plus 2ab plus b squared. So, squaring the first one, what's x2 squared? Then you use everything. Plus 2 times that is 2x squared, plus the last one squared is 1. Now, therefore, does the left-hand side equal the right-hand side? Therefore, therefore, you can say a squared plus b squared is c squared, therefore, it is a Pythagorean triad. Do you get the idea? If I call this one A, and that one B, and that one C, I want to see if A squared plus B squared is equal to C squared. How about that? Okay?
I do not like it. Stop it.
And I will pause so I don't get all the extra The question B, C, D, that's no big deal. You can write that down later. Go to your textbook and copy it. What we're going to do, we're going to start working this out. So, part A. These are our answers. Girls, you need to be quiet. I need to talk about this with you. You have to show that KL squared minus KN squared is equal to PL squared minus PN squared. Now, before you even start, identify the triangles that those sides are in. KL squared, so we're using this triangle here. Would you agree?
Yes.
All right, so I'm going to put a dot in that one. KN squared, which triangle's that one in? This one. Put a dot in that one, right? Girls, the problem is you've got a lot of right angle triangles here, and you've got to work out which one you're going to use. So, yes.
Basically just asking you if KL is equal to PL.
No. Girls, they're asking you to prove this result, that KL squared plus KN squared is equal to PL squared. Now, PL is also in this triangle, so that's not too bad. So at the moment, I can say, look, I'm just going to use that triangle and this one, and PN squared is also in that triangle. So let's use, girls, by looking at that, it's identifying which triangles to use. I mean, you could have said that PL is also in this one, but what, you want to use 4 triangles?
In the triangles.
The dots in the triangles are saying KL is in this triangle. KN is in that one. PL, you could say, is in that triangle. PN is in that triangle. So let's do Pythagoras' theorem in those two triangles with the dots. It's looking at the question and what you're trying to prove and how you're going to start. Because, girls, you could do Pythagoras' theorem in these 4 triangles and you're going to do a lot of work and maybe get nowhere. Yes. All right. No. So what do we know about Pythagoras' theorem? That the 2 shorter sides squared equal the longer one. So let's go in triangle KPL. What do we know? That the 2 shorter side squares, which are KP squared plus PL squared equals KL squared. Good. And we said that we would do the same. What I'm going to do, I'm going to leave a line there because I'm going to come back to it. Girls, notice in the question, is PL in the question?
Yes.
KL in the question? What's not in the question? All right, because KP is not in there, I'm going to make KP what I call the subject of the formula. So KP squared, I want to take everything over to the other side, and what do I get? KL squared minus PL squared. I'll show you why I'm doing that in a minute. So I've worked with the first triangle, and because KP squared is not in what I'm trying to prove, I've put it on its own on the left, and I've put everything else over to the right. Does that make sense? Now, I'm going to do this triangle here with the other dot. So, in triangle KPN, what can I write? What are the 2 shorter sides? KP squared plus NP squared, or PN squared, equals KN squared. Now, I'm going to do the same thing again. Because KP squared is not in there, I'm going to make it the subject. KP squared equals KN squared minus PN squared. Now, the other reason I did this is, you know, KP, isn't it the common side of both triangles? So, if do you notice that KP is the common side for both those triangles? Because it was the common side, it's the thing that links the 2 triangles together. That's also why I made KP squared the subject of the formula. So now, if that's equal to KP squared and KP squared equals that, so if KP squared equals that and KP squared equals that, I'm going to call this equation 1 and equation 2. I'm just going to say sub equation 1 into equation 2. Oh, wait, you haven't done simultaneous equations. Keep it there. So if KP squared equals that and KP squared equals that, doesn't that equal that? So therefore, so keep that. Yes. KL squared minus PL squared equals KN squared minus PN squared. It's almost what you're trying to prove. What do I need to move? I need to take the PL over there and the PN here. I've got a problem. Have I written the question out wrong? There's a problem. Oh, no, there's not a problem. I've got to move the KN over. So I'm going to keep the KL squared here. If I move the KN over, does it become positive or negative? Right. I'm going to keep the minus PN squared here. The PL squared needs to go over and it becomes positive. And that's your result. So girls, notice what we did. There was a common side between the 2 triangles, and that common side I made the subject of the formula. And I said KP squared is that, KP squared is that. That eliminates KP squared. Because if I say, well, it equals that and it equals that, then they're equal to each other. Girls, what I'm going to do tonight, I'm going to keep filming this. You watch the video from 24 minutes on to finish this question. Plus, I'll put 2 more videos up. Homework will be just to watch and copy the videos. Okay? All right.